Okay, so today we're going to talk about section 2.1 on linear functions. You may hear my dog barking in the background, but it hopefully shouldn't be too prominent on the recording. Um, so, in order to discuss this idea of linear functions, let's hop right into an example here. As you hop into a taxi cab in Las Vegas, the meter will immediately read $3.50. This is the drop charge made when the taxi meter is activated. After that initial fee, the taxi meter will add $2.76 for each mile the taxi drives. So, with this information, we will might want to ask, uh, is it possible to model this scenario with a function? Well, let's see. Let's choose some descriptive variables. Let's say that M stands for miles. And let's say that the variable C represents cost in dollars as a function of miles. Then I could refer to this function as C of M. Well, I know that C of 0 is $3.50. I wanted to write the dollar sign there, but I'll just write the number. I know that C of 0 is $3.50 because I pay this $3.50 drop charge regardless of how many miles the taxi drives. Then for each mile, I add $2.67 to this cost. So C of 1 will be $3.50 plus 2.67. And this is $6.17. C of 2 is $3.50 plus 2.67. Plus 2.67, I add another $2.67 for this second mile. This gives me $8.84. If I drive a third mile, this would be C of 3. I have $3.50 plus $2.67 plus $2.67 plus $2.67. This is $11.51. From this, we might observe a pattern here and conclude that if I drive some number m miles, then I'm going to pay a price that is calculated by this function, C of m equals $3.50 plus $2.67 times m. Because I start with this $3.50 drop fee, and then for every mile increase, I add $2.67. So notice here that this equation consists of two quantities. I have a fixed charge that does not change based on the input. This is fixed. It's always $3.50. Then I have some number here that does change with respect to my input. This $2.67 by itself is a rate of change. In this equation, we see that my rate of change is being multiplied by my input value. And notice here that my rate of change, this rate of change, is constant. The rate of change itself does not change. I'm always adding $2.67 at each step. I'm not adding any other amount. All right. And if I were to graph this, let me pull up a Desmos tab and do that for us. If I graphed this function, you would see, let me see, what should I restrict this graph to? I'll restrict it between 0 and 20 on the x-axis, 0 and 60 on the y-axis. There we go. Here, we see that this graph starts here at $3.50. And every 1 unit increase, this goes up by $2.67. Notice that this graph is a straight line. This is why we call these linear functions, because their graphs form a straight line. In fact, that's part of the definition of linear functions that we're about to write. So, a linear function is a function whose graph produces a line. Linear functions can always be written in a certain form. These can always be written in the form f of x equals b plus mx, or f of x equals mx plus b. These two things are equivalent because addition is commutative. Oh, I didn't realize that that was making a marker as well. I can't erase that? Huh. Okay, I accidentally drew all over this with my mouse, and now I can't erase it. Let me try. Yeah, okay. Sorry about that. It literally will not let me erase that. So, let me rewrite this. Or f of x equals mx plus b. These two things are equivalent because addition is commutative. The order in which you write the addition does not matter. Here, this number b is the initial or starting value of the function. This is when the input x equals 0. And here m is the constant rate of change of the function. So m is the constant rate of change. This is also called slope. The slope of a function determines if the function is increasing or decreasing. So if my slope m is greater than 0, then my function is increasing. If m is less than 0, my function is decreasing. And if m equals 0, this means that my rate of change is 0. So my rate of change is 0. Which means that my function is constant. It's a horizontal line passing through the point 0b. This neither increases nor decreases. Let's see, let's look at an example. This is a bit of an older example. Just because not many people purchase, I know not many people purchase music anymore. But you know, some people do purchase music. Some people like to still own it, which is, you know, that's totally cool. So let's say Marcus currently owns 200 songs in iTunes. Every month he adds 15 new songs, so he buys a new album every month. Write a formula for the number of songs in his iTunes collection as a function of the number of months m. How many songs will he own in a year? Well, we say that no matter what, he's starting with 200 songs, right? So n of 0, this is 200. If I think about what n of 1 would be, this would be 200 plus 15. I would have added 15 songs. If I think of what n of 2 would be, this would be 200 plus 15 plus 15, right? I would have added 15 songs and then added 15 more after 2 months. So if I create a function n of m that models the number of songs in Marcus's iTunes collection as a function of months, then this would be 200, which is the number of songs that he has currently, plus 15 times the number of months, which is m. With this formula, I can predict how many songs he'll have in a year. That's the second part here. How many songs will he own in a year? Let's see. So a year is 12 months. So I'm looking for n of 12. This is 200 plus 15 times 12, which is 200 plus 180. So Marcus will own 380 songs in 1 year. Let's look at calculating rate of change. How do I find a rate of change, or how do I find a slope? So if I'm given two values for the input, x1 and x2, and two corresponding values for the output, which we can call y1 and y2. I wanted to erase. There we go. Or a set of points that we can call x1, y1 and x2, y2. If we wish to find a linear function that contains both points, we can calculate the rate of change m by doing the following. M is equal to change in output divided by change in input This is sometimes represented as delta y divided by delta x. And given the information that I have here, this is y2 minus y1 divided by x2 minus x1. The rate of change is also called the slope of the line. So note that in function notation, if I'm talking about function notation, y1 is the same thing as f of x1, and y2 is the same thing as f of x2. So I could write that m is equal to f of x2 minus f of x1 divided by x2 minus x1. I could write it this way instead. And let's look at an example using this. We're just going to change this instead. Let's see. This has the population of a city. We're going to change a city to Sanford, North Carolina. Because Sanford, North Carolina's population kind of roughly matches up with the population numbers that I'm given here. So the population of Sanford, North Carolina increased from 23,400 to 27,800 between 2002 and 2006. Find the rate of change of the population during this time span. So the rate of change will relate the change in my population to the change in time. I'm looking at people per year is what I should be looking at for a unit in the long run here, right? Notice that my population increased between 2002 and 2006, so of course my rate of change should be positive, right? If I get a negative rate of change from this, then I obviously messed up somewhere. So we're going to take our years as our inputs and the corresponding populations as the outputs. So maybe I can label over here. I'm going to let x1 be 2002. I'll have x2 be 2006. Then y1, the population that corresponds to 2002 is 23,400. y2, the population that corresponds to 2006 is 27,800. So now, if I'm trying to find the rate of change, this is y2 minus y1 over x2 minus x1. This is 27,800 minus 23,400 divided by 2006 minus 2002 27,800 minus 23,400. That's 4,400. Divided by 2006 minus 2002 is 4. 4,400 divided by 4 is 1,100 people per year. Let's look at a couple more here. The pressure P in pounds per square inch on a diver depends on their depth below the water surface, D, in feet. Following the equation, I want to modify this. Wait, can I erase things? Where am I? Oh. Okay. Following the equation, P of D equals 14. Oh, some of this stuff got reversed whenever it copied and pasted. That's interesting. 14.696 plus 0.434D. Interpret the components of this function. So here I don't want to necessarily even write a function. Well, the function's given to me, right? So I can't really write anything to begin with. But it wants me to take the information I've been given and interpret these numbers. What do they mean? So I have some initial amount of pressure, right? This initial amount, 14.696, this means that at a depth of 0 feet, the pressure on the diver will be 14.696 psi. My rate of change, 0.434. This is that the pressure on the diver increases by 0.434 psi. For each foot, their depth increases. Here's another example. I'm not trying to make these dots. I'm trying to just click and paste. There we go. It's interesting how things get turned around when you copy and paste here. So if f of x is a linear function, f of 3 is -2, and f of 8 is 1, find the rate of change of this linear function. Well, here I can use the definition of rate of change, where slope or rate of change is f of 8 minus f of 3 divided by 8 minus 3. F of 8 is 1 minus f of 3 is -2 divided by 8 minus 3 is 5. 1 minus -2 is 1 plus 2, which is 3, divided by 5. This is my slope. or my rate of change. And let's go ahead and use this information to find an equation for the function. So I found this slope. I know that linear functions come in the form f of x equals mx plus b. This means that this function has to be in the form f of x equals 3/5 x plus b, but now I need to find what b is. And let's remember, I'll write it down here again. F of 3 was -2 and f of 8 is 1. So what I need to do is plug in one of these bits of information. For instance, I can find f of 8. F of 8 is what I get whenever I plug 8 in for x. And I happen to know that f of 8 equals 1. So since I have f of 8 on the left-hand side of this equation, I can replace it with 1. And this is equal to 3/5 times 8. Well, 3 times 8 is 24, so this is 24/5 plus b. I can subtract 24/5 from both sides here. And I get that b is equal to, 1 is 5/5, so 5 minus 24 is -19/5. So the equation for this function is f of x equals 3/5 x. I could say plus -19/5, or because really the plus sign is kind of unneeded here, I could just say -19/5. It's also completely fine if you write this as f of x equals -19/5 plus 3/5 x. This is the same thing. Same idea here. Let's try another one. This one is a word problem. Working as an insurance salesperson, Ilya earns a base salary and a commission on each new policy. So Ilya's weekly income, I, depends on the number of new policies he sells during the week. Last week he sold 3 new policies and earned $760 for the week. The week before, he sold 5 new policies and earned $920. Find an equation for I of n and interpret the meaning of the components of the equation. So we're given 2 big bits of information here. We're told that when he sold 3 policies, he earned $760 that week. So since I'm told that I of n is what I want this equation to be, that means that I of 3 was 760. The week before, he sold 5 policies and earned $920. This means that I of 5 is 920. I can then set up my rate of change equation as being I of 5 minus I of 3 divided by 5 minus 3. This gives me I of 5 is 920 minus I of 3 is 760 divided by 5 minus 3 is 2. 920 minus 760 is 160 divided by 2 is 80. So I get that my rate of change here is 80. So I of n is going to be of the form 80 80n plus b. In order to find this b, I once again have to choose one of these things and plug it in. Let's say I choose I of 5. This is equal to 80 times 5 plus b, right? Because I of 5 is what I get whenever I plug 5 in for n. This means that I of 5 is 400 plus b. And now I know what I of 5 is. I of 5 is 920. So this is 920 equals 400 plus b. And when I subtract 400 from both sides, I get that b is equal to 520. So when I put all of this together, I get that I of n is, let's see, I had 80n plus 520. Or you could write I of n equals 520 plus 80n. Here, Ilya's base salary is $520 a week. 520 is the base salary. And $80 is the commission for each insurance policy he sells. This is the commission for each policy sold, because this is changing, right? This is this 80 is a rate of change. And let's look at an example with a table. Let's say we have a table and we want to write a linear function that represents our table values. Say we have a table that is W, which is number of weeks, and P of W, which is number of rats. Let's say we start off with 1,000 rats. After 2 weeks, that number increases to 1,080 rats. After 4 weeks, that number increases to 1,160 rats. And after 6 weeks, that number increases to 1,240 rats. Here, we might see that my initial value of rats is 1,000. So we might say that P of W is M times W, because W is our number of weeks here, plus 1,000. Now, we can either solve for M, or we can notice that the number of rats goes up by 80. Every 2 weeks. So if I wanted to find the rate at which the number of rats increases every week, I would take 80 and divide it by 2, and I'd get 40 rats per week. So this equation then becomes P of W equals, let's see, 40W plus 1,000. And let's just look at a few more examples here. Let's look at some functions and determine, are they increasing or decreasing? F of x equals 4x plus 3. Notice that my slope here is positive, so this is increasing. K of x equals negative 4x plus 1. Notice that my slope here is negative, so this function is decreasing. J of x equals 1/2 x minus 3. Notice that my slope is positive, so this is increasing. And let's see. M of x equals negative 3/8 x minus 3. My slope here is negative, so this is decreasing. And let's see, let's find a linear equation. Let's find the linear equation. Passing through the points 2, 4 and 4, 10. Here I can label these, let's see, x1, y1, x2, y2, and this helps me find my slope potentially. So m is 10 minus 4 over 4 minus 2. This is 6 over 2, which is 3. So I know that f of x equals 3x plus some b. I know here that f of 2 is 4, since I have the point 2, 4. So I know that f of 2 is, which is equal to 3 times 2 plus b. Well, I know this is 4. This is 6 plus b. I subtract 6 from both sides, and I get that b is equal to negative 2. I'll show me subtracting the 6 here. So my function here is f of x equals 3x minus 2. Let me look at some of our homework questions here. Here. This is a good example. On a bicycle, here, I'll zoom in for this. On a bicycle, Karen rides for 8 hours and is 82 miles from her house. After riding for 11 hours, she is 112 miles away. What is Karen's rate over the last 3 hours in miles per hour? Well, let's see. I know that f of 8 is 82. I know that f of 11 is 112. Notice here it just wants me to find the rate of change. It doesn't want me to find an entire equation, right? So this means that, let's see, f of 11 minus f of 8 over 11 minus 8. This is how I'd find my rate of change. F of 11 is 112 minus f of 8 is 82 over 11 minus 8 is 3. This is, let's see, 112 minus 82, that's 30, divided by 3. This is 10 miles per hour. Let's see. Let me look at some more stuff here. Let me see if this copies over correctly. Okay, I just need to erase some things. Okay. A clothing business finds that there is a linear relationship between the number of shirts N it can sell and the price P it can charge per shirt. In particular, historical data shows that 2,000 shirts can be sold at a price of $12, while 3,000 shirts can be sold at a price of $7. Give a linear equation in the form of P equals MN plus B that gives the price P they can charge for N shirts. And let's see. Here we want to round the value of our slope to 3 decimal places. That direction is given after the answer box in this case. So I know that, let's see, F of 12, if I charge $12 a shirt, I can sell 2,000 shirts. If I charge $7 a shirt, let's see, or rather, I want my price P to be the output here, right? Not my input. Okay. And I want the number of shirts to be the input. Okay, okay. Sorry, see, sometimes even I make mistakes whenever I don't read the problem entirely thoroughly. So let's look at this again. I want my number of shirts to be the input, N. So I want then for F of 2,000 to be 12. I want for F of 3,000 to be 7, because the price P should be my output here. It's the thing on the left-hand side of the equation. So then I can say, let's have F of 3,000 minus F of 2,000 divided by 3,000 minus 2,000, and this will be my rate of change, M. Well, F of 3,000 is 7, F of 2,000 is 12, so this is 7 minus 12 divided by 3,000 minus 2,000 is 1,000. Seven minus 12 is negative 5, so this is negative 5 divided by 1,000. And this is negative 0.005. So my function is in the form. I'm going to say P of N is equal to negative 0.005 times N plus B. Now I have to find out what this b is. So I have to choose one of these bits of information to plug in. Maybe this f of 2000 equals 12. So, in other words, well, I guess I should have had p of 2000, right? Really, because this is p of n, but I'm sure y'all understand what is going on still. So, I should have p of 2000. This is negative 0.005 times 2000. You could have chosen p of 3000 instead, and you still would have gotten the same answer. I know that p of 2000 is equal to 12, right? The cost, you can sell 2,000 shirts at a price of $12. So this is 12 equals negative 0.005 times 2,000. This is negative 10 plus b. Then to solve this, I add 10 to both sides, and I get that b equals 22. So whenever I put all of this together, I get that p equals negative 0.005 times n plus 22. And that's my answer. And this is it for section 2.1.